Did you think that the engines of the aircraft were responsible for generating lift? Well, let's find out how an aircraft actually flies, or in other words, how the aircraft actually generates lift. Before telling you the truth or the reality of how aircraft generates lift, let's check out some of the theories which have led people to false thinking about flying. And trust me, it's not good. These theories are big nightmares for an aerospace engineer, and you'll realize this at the end of this video. So let's see the first false theory, which is named as the longer path theory, also known as the equal transit theory. This theory tells us that the airfoils, which are the cross-section of the wing, are shaped with the upper surface longer than the lower surface. So when the air strikes the leading edge, it gets separated, and the air molecules above need to travel a longer distance compared to the air molecules which are below. This implies that the air molecules above must travel faster than the air molecules below in order to meet at the trailing edge of the wing. And from the Bernoulli's principle, we know that faster velocity means lower pressure and lower velocity means higher pressure, provided there are no gravitational effects, or in layman language, no difference in height. So, lower pressure above and high pressure below. This difference in pressure causes a net force upward, and guess what? That force is lift. Ridiculous theory, right? Don't think so? Well, ask yourself a question that how can the air above magically meet the air below the airfoil? Of course, it might happen in Hogwarts, but we live amongst muggles, in a muggle world. So let's check out what the muggles must know. Now, although the above theory is wrong, one thing is surely correct, that a difference in pressure is required for generating lift. To create this pressure difference, any one or both of these things should be met. That is, airfoil should be cambered and or airfoil should be inclined at a positive angle relative to the flow direction. Next, viscosity, which is the friction between adjacent layers of fluid, plays a crucial role in generating lift. How? Let's check it out. Now this viscosity leads to the formation of starting vortex, which is nothing but a whirling mass of air in counterclockwise direction. But our Mother Nature says we need to conserve angular momentum, so there is an equivalent motion around the airfoil in clockwise direction. This takes the form of circulation around the airfoil. So when the velocity vectors of the circulation is added up to the free stream air velocity vectors, we get a higher velocity above the wing and lower velocity below the wing, and these air molecules never meet at the trailing edge. And let's remember our Bernoulli sir again. He said faster velocity means lower pressure and lower velocity means higher pressure. So above the wing we have low pressure and below the wing we have high pressure. And now we can say we've got lift. Job done, right? But then why do we have the second false theory, which is named as the skipping stone theory, wherein the lift force is simply a reaction force and as a result of air molecules striking the lower surface of the airfoil as it moves through the air. Now this case is similar to that of a flat rock when thrown at a shallow angle across a body of water, hence the name skipping stone theory. Over here our Newton's sir's laws come into action and they can solve this mystery. We know that lift is a force, and from Newton's second law, force equals mass times acceleration, and acceleration is defined as time rate of change of velocity. So we see that force is responsible for change in velocity, and likewise a change in velocity generates a force. Keeping this in mind, when both the surfaces of the airfoil deflect or turn the air, the local velocity of the air is changed in its magnitude direction of both. The bottom surface deflects, or we can say the air bounces off the wing, and the upper surface bends the air around, or we can say the air sticks to the upper surface and is guided down by the Coanda effect. Coanda effect? What is that? Well, we can say it as a love effect between the air molecules and the surface, and air molecules has a tendency to stay attached to the convex surface, in this case the upper surface of the airfoil. So the combined effect is that the air pushes the airfoil up and back, which is nothing but lift and drag. This whole scenario can be thought of as a result from Newton's third law, which says if you want to go somewhere, you need to leave something behind. Just interstellar things. But hang on, why there are two explanations? If this explanation is correct, then the previous explanation must have some flaw. Or if the previous explanation is correct, then this explanation must have some flaw. Well, both the explanations are right in their own way. It's just two different ways of looking at the same thing, that is, how aircraft generates lift. Still confused? No problem. Replay the video and you'll get it the second time, most probably. Until then, see you next time in another video. Oh, by the way, the engines which I talked about earlier, their only role is to give thrust.